All right, welcome to The Explainer. Today we're going to tackle a question that I know drives everybody crazy. Why does your internet feel super fast one minute and then painfully slow the next? Well, the answer isn't what you think, and it all comes down to two very different kinds of speed.
I mean, we've all been there, right? You're paying for this super fast internet, but your game is lagging like crazy, and yet Netflix is streaming in 4K without a single hiccup. What is actually going on here?
Well, it turns out that internet speed isn't just one simple number. Nope, it's really more like a tug of war between two totally different but super important metrics. And you know, getting a handle on them is the key to finally figuring out what's causing that frustrating lag.
Okay, so to make this crystal clear, we're going to use a really simple but powerful analogy. For the next few minutes, just picture your internet connection as a massive highway system, but for data.
So, on this data highway of ours, we have two key things we're measuring. First up is latency. Just think of this as the travel time for one single car. How long does it take for one little packet of data to get from point A to point B and back again? And then you've got throughput. This one's all about volume. How many cars or how much data can actually pass a certain point on the highway all at once?
All right, so keeping our highway analogy in mind, let's dig into what actually affects the travel time of that single car versus the total flow of traffic. They're definitely related for sure, but they are not the same problem.
So first up, let's talk latency. You might know it as ping or ping time. It's all about delay, pure and simple. We measure it in milliseconds. That's thousandths of a second. And with latency, you always want a lower number. The lower, the better. It just means your data is zipping to its destination and back with almost no delay.
So what's causing these annoying delays? Well, for one, sheer physical distance. I mean, a longer road just takes more time to travel, right? Then you've got network congestion. That's literally the digital version of a rush hour traffic jam. Things like security protocols. Think of those like toll booths. They add these tiny, necessary delays that can add up. And sometimes a piece of equipment, like a router, just gets completely overwhelmed and drops your data. That forces your little car to turn around and start its trip all over again.
Okay, now let's switch gears and talk about throughput. This isn't about the speed of that one car anymore. This is all about the total volume of traffic that actually successfully makes it to the destination. We measure this in megabytes per second, or MBps, and with throughput, a bigger number is what you're after. The higher, the better.
You know, your highway's total flow is always going to be limited by its weakest link. Bandwidth is the big one, of course. That's just the total number of lanes you've got to work with. But you also have to factor in things like packet loss. That's like cars literally getting lost or damaged along the way and needing to be resent. And sometimes it's the fundamental design of the whole road system itself that's the bottleneck. Okay, so we've got speed and we've got volume. But here's where it gets really interesting and a little complicated. Latency and throughput don't just exist in their own separate worlds. No, they're locked in this constant feedback loop where each one is directly messing with the other.
And this is what that feedback loop looks like. So if your highway has a massive traffic jam, that's your high latency. It's pretty obvious that's going to reduce the total number of cars that can get through, right? That tanks your throughput. But it works the other way too. If your highway is just too narrow to begin with and can't handle the sheer volume of traffic, that's low throughput, it's going to create these huge backups that make the travel time for every single car seem way longer.
This also brings up a really critical point. We have to be careful not to mix up throughput with bandwidth. Bandwidth is all about the potential of your network. Think of it as the total number of lanes your highway was originally built with. It's the absolute theoretical maximum.
Here's the perfect way to think about it. You might have this massive 10-lane superhighway. That's your huge bandwidth. But if there's a giant crash blocking 9 of those 10 lanes, your actual throughput is going to be absolutely terrible. See? Throughput is your real-world, in-the-moment performance. It's not just the big number they advertise on your internet bill.
Okay, so knowing all of this, how do we actually improve a network? I mean, it's not always as simple as just adding more lanes to the highway. Engineers actually use some really clever techniques to manage both the speed and the volume.
One of the absolute cleverest solutions out there is something called caching. So instead of having to pull data from a server that's halfway across the globe every single time you need it, networks use these things called content delivery networks, or CDNs. What they do is store copies of popular stuff like a hit Netflix show on local servers that are geographically much closer to you. This just dramatically shortens the data's travel distance, and that directly slashes your latency.
And you know what else matters? The type of vehicle your data actually travels in. Seriously. So for something like streaming a Netflix movie, the system can use a protocol called TCP. Think of this like a big, reliable, armored truck. It's a little slower, sure, but it takes its time to make absolutely certain that every single piece of data arrives safe and sound. But for gaming? Oh, for gaming, you need UDP. That's your speedy motorcycle courier. It just fires off data as fast as possible, prioritizing low latency over perfect 100% accuracy. Because in a game, a few lost pixels here and there don't really matter, but a half-second delay, that's game over.
And finally, there's this really cool thing called quality of service, or QoS for short. This is basically the internet's version of a VIP express lane. It's smart enough to identify time-sensitive traffic, you know, like your important Zoom call or your competitive online game, and it gives that traffic priority, letting it just zoom past all the other congestion. This is how you get that super smooth, low-latency experience for the stuff that really counts.
Okay, so let's bring this all home. Why does any of this technical stuff actually matter for you and your everyday internet use?
All right, so here's the bottom line, the main takeaway. For anything that's interactive, anything happening in real time, we're talking online gaming, video calls, low latency is king. Even the tiniest delay is super noticeable. But for anything that involves just consuming a massive amount of data, like streaming a 4K movie or downloading a huge game file, that's when you need high throughput to handle all that sheer volume.
So ultimately, the best internet connection isn't just about the one with the biggest number on the box. It's the one that's perfectly optimized for what you need to do. A competitive gamer and a 4K movie buff have completely different ideas of what a fast connection is. And now you know exactly why.
So the next time your connection starts to feel sluggish, you'll know the right question to ask yourself. Am I stuck in a data traffic jam, or is my highway just not wide enough? Understanding that difference, well, that's the first real step to getting a faster connection. Thanks for joining us for this explainer.